Next, we will discuss how to find the probability of an event. We already know that the probability of an impossible event is 0, and the probability of a certain event is 1. As a result, the probability of any other event must be between 0 and 1. The question that we will try to answer next is about how to find the probability of any given event. And before we start answering this question, we need to understand that for every event there is an experiment for which there exists the sample space, which consists of all possible simple outcomes, using which we can define an event as a set of simple outcomes. Consider the following two examples, tossing a coin and driving to work. Both experiments have two simple outcomes. Tossing a coin may result in heads or tails, and driving to work may result in an accident or not. But there is one conceptual difference between these two experiments. To see the difference, let's answer the following questions. Is there reason to believe that the heads are more or less likely than tails? And is there reason to believe that to get in an accident is as likely as not to get in an accident? Turns out that there is no reason to believe that when tossing a fair coin, the chances of getting heads are any different from getting tails. Such experiment is said to have equally likely outcomes. On the other hand, there is no reason to believe that the chances of getting in an accident are the same as the chances of not getting in an accident. Such experiment is said to have not equally likely outcomes. Consider another two examples, rolling a die and counting credit cards in the wallet of a randomly selected person. Both experiments have 6 simple outcomes. Rolling a die may result in any number between 1 and 6, and the number of credit cards in the wallet of a randomly selected person can vary from 0 to any number. Again, there is one conceptual difference between these two experiments. To see the difference, let's answer the following questions. Is there a reason to believe that 1 or 3 are more or less likely than 4 or 6 when rolling a die? And is there reason to believe that it is as likely to have no credit cards as more than 5? It is obvious that there is no reason to believe that when rolling a fair die, the chances of getting any number are different from any other number. On the other hand, there is no reason to believe that the chances of having no credit cards are the same as the chances of having more than 5 credit cards. Most classical experiments have equally likely simple outcomes, but in real life, most of the experiments do not have equally likely outcomes. So it is important to be able to work with both types of experiments. When working with an experiment that has equally likely simple outcomes, we will be using an approach called classical. And when working with an experiment that has not equally likely simple outcomes, we will use an approach called empirical. Next, we will discuss two different approaches to find the probability of an event, classical and empirical, and which approach to use will depend on whether the experiment has equally likely simple outcomes or not.